Hey, in this tutorial we're going to look at graphs of reciprocal trig functions. So they're our sec, cosec and cot functions. Okay, so remember that sec is defined as 1 on cos of x. So just drawn our graph of y equals cos of x here. Okay, and so remember we're 1 over cos of x. So you can see we've actually drawn on some asymptotes here, and they make sense because at these points here, this is where cos equals 0. So when we're trying to do 1 divided by 0, then it's going to be undefined. It doesn't work. Okay, so we've got to have vertical asymptotes everywhere that we have an x-intercept. Okay. Also, you need to look and go, okay, well, what's happening at our different points? Well, here, okay, at x equals 0, then we have the point 1, y equals 1. Okay, so then if we've got 1 divided by 1, it equals 1. So we find that that is a point on our graph as well. Okay, and now we're doing 1 divided by, say somewhere here is going to be a half, which is going to equal 2. So we're going to be up here somewhere. Okay, and the same if we went the other way, we'll have a point over here. So in the end, what we get is something that looks like that. Now we'll have the same thing happening wherever we're above our x-axis like this. So we're also going to have a point here and a graph that looks like that. And same with down here. And in between you need to think, well, down here we've got -1. So that's 1 divided by -1, which gives us -1. Okay, and if we came across a bit, there'd be a point where it equals a half. So 1 divided by -half gives us -2. So we're going to come down further. So in this case, it's going to be flipped up the other way, which is going to be the same here. Okay, so you can see that's what our graph of cosec looks like. Now I've got our domain and range here, but as you can see, it's actually quite difficult with our domain and range. Okay, so our range is going to be all real numbers excluding between -1 and 1. Actually, that should be round bracket. Okay, and our domain, well, that's going to be a little bit trickier to define, so I won't actually worry about that because it's a little bit beyond the scope of what we're doing anyway. For cosec, remember that's 1 over y equals sine of x, so we've drawn our graph of sine of x there. Okay, and as you'd expect, it's going to look very similar to this, okay, because these are very similar, they've just got a phase difference. Okay, and same here. So again, wherever we are above, okay, we're going to be above as well, like this. Wherever we're below, we're going to be below. Okay, so just matching up what we've got. Oh, sorry, I've mucked that one up. Sorry about that little mistake there. Okay, and now cot is a little bit different though, this one. Okay, it's not quite as intuitive to see how you would get to this one. Okay, but again, what we have here, okay, is wherever we have an x-intercept. Okay, well, sorry, we've got, for a start, this is y equals tan of x, okay, because cot is 1 over tan. So again, wherever we've got an x-intercept, we've got to have an asymptote. Okay, and it's a little bit counterintuitive this, but what we do is, it actually looks very, very similar. Okay, it's just we actually come down this other way. So it looks very, very similar to tan. Okay, it's just that it slopes the other way. So you can get the idea there. Okay, again, this domain, so this range is the same. We've got all real numbers excluding from -1 to 1. Okay, and this range here is going to be all real numbers. Okay, and again, the domain's a little bit tricky because there's so many ones that we're going to exclude, so we won't worry about defining that. Okay, so we'll flip over and we'll look at some examples that we have here. Okay, so we've got, here's the graph of y equals 2 cos of x, okay, to sketch the graph of y equals 1 on 2 cos of x, where x is between negative 2 pi and 2 pi. Okay, so what we really want to do to start off with is actually draw our original function, y equals 2 cos of x. Now you do that simply because it actually tells us to use the graph of that. Okay, it's always a good starting point. Okay, so we're starting at 2 because of our amplitude here of 2. Not the best graph in the world, this one. It'll suffice. There we go. And so we simply need to now go, okay, well, where are our vertical asymptotes going to be? Well, it's going to be wherever our x-intercepts are, so obviously here. Here. Okay, and you'll see I'd putting down a little bit of info here about our graph to help us out. Our period was 2 pi. Yep. Okay, amplitude was 2. Yep, we've taken care of that as well. We don't have any horizontal or vertical translations. So now we simply just need to finish this one off. Okay, now it's a little bit different to what you'd expect. Okay, because you need to think, okay, well, we're 1 over our values. Okay, so you need to be careful not just to curve down and come here and use our 2 as the bottom of our curve for our new graph, because remember it's 1 divided by that, so it's 1 over 2, so it's actually a half. So it's actually going to be down here. And after you've gotten that, you can simply draw them. Okay, here we're below, so I'm going to start a bit here. Remembering that we should always really be drawing in pencil for our graphs. Okay, I'm just using Texter so that you guys can see it well. Okay, so it should be something like that. Okay, so we'll go on to the next one. Okay, use the graph of y equals sine of x on 2 to sketch the graph of 1 over sine of x on 2. Again, we're from negative 2 pi to 2 pi for our graph. Okay, so we need to just work out this one. So you can see here we've got our period, it's actually 4 pi, okay, because there's x on 2. Okay, our amplitude is 1 and we've got no vertical or horizontal translations at all. So what that means is when we graph it, okay, that we're going to come out like this all the way to 2 pi, okay, and then same the other way. Okay, and we have to use this information to do our sketch. Okay, so again we need to go, well, where are our vertical asymptotes? Well, we have one here that is the y-axis. We're also going to have ones here. Okay, and then we go, well, our maximum here is 1. 1 divided by 1 is 1, so we are going to use that point. Okay, so we're going to come down, back up, and this one we're going to be coming this way. Okay, so getting there, we've got one more to go. Okay, so we have used the graph of y equals 10 of x on 2 to sketch a graph of 1 on 10 of x on 2, and again we're from negative 2 pi to 2 pi. So all I've done there is set up some axes, okay, and put on our asymptotes for our tan graph. So our period is 2 pi this time, instead of being pi as it usually is for 10. So just sketch what we've got. Okay, so it's not too bad for this one. So all we need to do is we need to work out our new asymptotes, okay, which are going to be, I'll do them in different colours so we don't get confused. So again, they're at our x-intercepts. Okay, so there's going to be one here as well. And we'll have another one down here. Okay, and then we can simply draw on what our new graph has to look like. There we go. Okay, we've got another example to look at, and this is our last one. Okay, so I'm going to sketch a graph of y equals 1 over sine of x plus pi on 4 plus 1. Okay, over the domain of negative pi to 2 pi. So a slightly different domain, but it doesn't matter too much. Okay, so what we're going to do is look at, just to start off with, ignore this 1. Okay, and we're going to just start off with this. Okay, so just going to worry about sketching to start off with, sine of x plus 4. Okay, so for our graph of y equals sine of x plus 4, well, the amplitude is 1, the period is 2 pi, but we've been translated to the left by pi on 4. Okay, translated to the left of pi on 4. Okay, and that's because we're a plus, okay, so we move to the left. Okay, so what that means is usually we'd start here and come up, but we're actually going to start here to come up. Okay, so our graph is going to look something like this. Okay, and then we're going to come back down here. Okay, so a graph of y equals sine of x plus 4 is going to look something like that. Okay, so now we need to go, okay, well, where are our x-intercepts? Okay, make them our vertical asymptotes. Okay, now all we need to do here is go, okay, well, where would we usually be? Well, we'd usually be here, 1 over 1 gives us 1. However, we're going to actually add 1 to it now, because we're actually going to move the whole thing up 1. So instead of coming through 1 here, we're going to come through 2. So okay, come down like this. Okay, so we've got that one. Okay, and there'd be part of 1 here. Okay, we're not going to see a lot of it. Something like that. Okay, and then for this one here, okay, well, we're at negative 1. Okay, so we're going to add 1 to it. So we're actually going to come through the x-axis there. We're going to have a turning point there. Come up and touch it, and then come back down. Okay, and again, we've got a turning point here, so we touch it up here, come down, and there'd be part of what we've got here as well. Something like that. And we're all done. So hopefully that's enough to get you through the questions on that section.